type.
Right. Now,
Okay.
why ground any of it?
Right.
All right. Primarily to avoid fires. All right. The just like in your home, you have fuses and circuit breakers that protect from overloads and whatnot. So you have two kinds of things that would trip a circuit breaker or blow a fuse. You could have an overload on the circuit. You plug too many curling irons, hairdressers, toaster ovens,
causes a
microwaves,
short.
all that. No, it causes an overload.
An overload, okay.
And because the wiring is resistive between the panel board and all those receptacles, as more and more load is drawn, that wiring heats up. And it could heat up enough to start a fire inside the walls. So to prevent that from happening, they put a circuit breaker in. Well, the other type of fault is a ground fault, where either within the equipment or external to it, if the wiring becomes damaged, you could have a fault to ground. In both of those cases, you need the circuit breaker to trip. Now, if you didn't have a grounded circuit, the only thing that could make that circuit breaker trip is overload.
Okay.
All right, so it wouldn't protect against a ground fault. So some piece of equipment could become energized, somebody walk up and touched it and get shocked. Now, take that same principle into the central office in a power plant. All right, 48 volts isn't going to shock anybody. But the most common failure in a central office is a ground fault, where either a piece of equipment fails internally and shorts to chassis ground, or a cable gets pinched in a cable tray, or somebody ran it around a threaded rod and it dug in. And you want to be able to trip the circuit breaker upstream at the source, so that you're not arcing and starting a fire in the cable tray or in the equipment or what have you. So the power plant needs a ground source at that point to give the circuit breaker something to fault to short to cause that breaker or fuse to open up.
Otherwise, it could cause a fire, you said, or
Otherwise,
worse.
Yeah. Well, an electrical arc, a sustained electrical arc burns at about 36,000 degrees Fahrenheit. That's like 4 times the surface temperature.
It's a heck of a lot of curling
so,
irons all plugged into one wall.
Yeah, it is. It'll curl your hair. Yeah.
Okay.
Or when you get the bill, when
Yeah,
your
exactly.
CO burns down, your boss is, you'll get, it ain't good.
No. So now we talked a little bit about the grounding. I have a few questions here on the grounding specifically. So if that was covered in what you just asked, like explain the main principle of an office ground bar. Does that go into what you just described, or is that different?
A little different. It's an electric protection issue. All right, let's take this home. Let's go to your home, and on the outside of your home, you'll have the electric company coming in. You'll have a meter outside, and then inside at the circuit breaker panel, the neutral bar will have a lead that comes out to ground, and then there's what's called a main bonding terminal, so that all your equipment grounds are tied to your neutral bar that's tied to some earth ground electrode, whether it's a ground rod or rods, water pipe, or both.
Mm-hmm.
And so that's one piece of it. All right, now you also have what the telephone company calls a network interface device, a NID, sitting on the side of your house, and that's where the cable pair comes in and goes to that. And inside that thing are protectors that if a cable lightning hits the telephone cable, or if there's a cross with a power utility cable on the telephone cable, you don't want the voltage to go too high in the home that could harm the customer. So that there are protectors in that network interface device, and they have to fault to ground in order to keep the potential low enough not to hurt somebody.
Okay.
All right, so that connects to that same ground source as the electric field. And so in a well-designed home, everything that's coming in from outside bonds together at one point and then goes to ground. And it's called an inter-system bonding terminal in the National Electrical Code. But basically, it's just a bunch of lugs in a bar and going to ground, so that all these things are bonded together, so that you don't have a great difference in potential between any of these devices out in the home.
Okay.
All right, so you don't want somebody on the phone and the electric line takes a lightning hit, and you got maybe a couple of a bunch of voltage in there that could hurt somebody.
Exactly.
Or cable TV or any of those things. So all of those items, water pipe if it's coming in a metallic pipe, ground rod or rods, they all become your electrodes, earthing electrodes. And then your electric service, your telephone service, your cable TV service, if you have that, or if you have a TV antenna mast or a CB radio or some kind of ham radio mast, any of these things, they all get bonded together at that inter-system bonding terminal and go to ground. All right, now
Okay.
let's go into the central office. We've got earthing electrodes in there. They're driven ground rods out there in various configurations that are used. And then you've got electric coming in, the house service board. You've got maybe a metallic building that could be a lightning target, or you've got lightning rods, all that stuff. All those things tie together on that bar. So that bar just becomes a big inter-system bonding terminal.
How big is one of these bars? Because it seems like it's got a lot of responsibility. Is it like a massive piece of equipment, or is it depending on?
Well, in a small facility like a hut or a cell site or whatnot, it's typically a copper or plated copper bar about so big, you know.
Okay.
In a large central office for like 500,000 lines or something like that, it's probably 5 or 6 inches wide by 3 to 4 feet long and a
Okay.
quarter-inch thick.
Okay.
And then they'll have conductors coming down from that that go to the ground field, driven ground rods, water pipe, all those sorts of things. And then a bunch of leads coming into it from various things looking for ground in the building.
How do they connect to the ground bar? I mean, do you lug it or like terminate it?
Usually they're lugs. Some people use exothermic welds, or some people call them CAD welds.
Okay.
But sometimes they weld to the bar. But it's really better if they use lugs and properly prepare it. If you've got just a plain copper bar and the lugs are placed on there, then they need to clean the bar of any oxides or grime or tarnish, typically with a mild abrasive, like one of those spun plastic scouring pads, like a Scotch-Brite pad. Sorry to use somebody's trade name, but that's really the best tool for that. And you clean it to a bright finish, and then you put a coating on there of a cosmoline grease. The trade name we use in the telecom industry is No Oxid A Special, made by a company called Sandchem. And there are other compounds out there, but most of the RBOCs prefer the cosmoline grease type. And what that does is keep moisture out of it, so it doesn't set up a corrosion cycle. And so now you have typically a tin-plated lug bolted onto a copper bar from these various things, and then the same thing going down the ground, or CAD welds. Now, a lot of people would prefer to use lugs over CAD welds, and I agree with that, because sometimes you need to disconnect something for troubleshooting. And
welding is significantly more permanent than
yeah,
unbolting a lug.
yeah, you can't unweld it.
You can't unweld.
Right.
Right.
Right.